So in this video, what we're going to work on are some more solving exponential and log equations. So let's recall that when we were dealing with exponential, that if I had 2 to the power of 3 and 2 to the power of x, I know that 3 is equal to x because they have the same base, okay? And we can manipulate our bases. So sometimes you might have a 9 and then you have a 27. And so we have to manipulate both, right? So 3 squared, again, to the power of x, 3 cubed. And again, what we're noticing is I have the same base, so I can focus purely on my exponents. So the question is, what do we do when we have different bases? So that's what we are going to focus on here, okay? So if I have a question that looks like this, if I say 2 to the power of x is equal to 5, I am not sure what I have to raise 2 to the power of to get to 5, okay? But what I do know is that I have a property that tells me I can bring down the exponent, okay? So remember, we have this lovely property called our power property that tells us that that n, right, goes to be in front, right? And then it purely becomes a multiplication problem. So whatever I do, I have to do to both sides of my equation. So what I'm going to do is I can apply a log or a natural log to both sides, right? So what does that look like? It looks like this. I'm going to put a log in front over here, and I'm going to put a log in front here. So now, again, I have all of this, and I have all of this. So why do I get to do that? Well, now I can bring my x in front. And so I have x log of 2 is equal to log of 5. I have made this become a multiplication problem. And now the only way to get rid of a log of 2, because again, log of 2 is a number, is to divide. So I'm going to divide both sides by log of 2. And I'm going to get log of 5 all over log of 2. All right? This is an exact answer. Right? If we want to find an approximate answer, we can plug it into our calculator. So let me pop up a calculator. So I'm going to say log of 5 divided by log of 2. And we're going to get this long decimal, and we really only care about the first couple of numbers. It's the 3 decimals are pretty good. So we can say 2.32, and then we can round it to 2. So 2.322 would be a perfectly acceptable answer. And so this is what's known as an approximate answer. We should be able to do both. Okay. So what happens if I have problems that have variables on both sides? So let's get rid of that. So if I have 3 to the power of, say, 2x is equal to 5 to the power of x plus 1. And I want to figure out what I need to do. Again, I have variables on both sides, so I need to bring my variables down. And again, there's no way to make a 3 become a 5 or a 5 to become a 3. Now, keep in mind the 2x is everything inside my, is being raised to my power, so I need to bring that in front. And all of this is now going to be multiplied, right? So why I'm bringing that up is because a 2 times x, this is just a monomial. But the x plus 1 is a binomial. And so I need to make sure that all of this stays multiplied. And I have to ask myself how I can get rid of my x's. I need to move my x's onto one side. Now, log of 5 is a number, right? It would be as if I said, 2x plus 1. And so I'm going to go ahead and distribute, right, that number out. So I would get 2x plus 2. So I can do the same thing over here. So this will give me 2x log of 3. And then over here is x log of 5 plus just 1 log of 5. So now I can kind of move this over to the other side by subtraction. So I'm going to subtract it, right, leaving you with log of 5 by itself over there. Now, just like we distribute something in, we can factor something out. Notice that they both have an x. So let's factor out the x. So that would look like 2 log of 3 minus log of 5 equal to log of 5. And now the 2 is, this long parentheses is just being multiplied by your x. So the only way to get rid of it is I need to divide all of that. So I'm going to take all of this and divide it. All right. So when I do that, my final answer, in my numerator, I have log of 5. In my denominator, I have 2 log of 3 minus log of 5. Now, if I wanted to use my my power property, my quotient property to simplify that, I can, but I don't need to. Okay, so let's see what this would look like as an approximate answer. So we want to be careful. I want to make sure that I keep this in my denominator, so I need to make sure that I use parentheses. So I'm going to have log of 5, right, divide by my denominator. So I'm going to open my parentheses, 2 log of 3, close my log of 3, minus log of 5. All right, and close my second set of parentheses. And so we get about 2.738. So 2.738. So again, this is an exact answer, and this is your approximate answer. Again, it's important that we should be able to find both. Now, how could you check to make sure that you were 100% correct? Well, we can plug it in. We can say, what is 3 to the power of 2 times this long answer? So I'm just going to say second ANS, and it gives me 410. And if I say 5 to the power of, and I want to click on that, so enter, and then plus 1, it should be exactly the same, which it is. All right, so yeah, we can always kind of test it out to see what's happening. All right, let's try one more. And get rid of that one more time. So why don't we try 2 to the power of x plus 3 is equal to 6 to the power of x minus 4. So if you want to go ahead, try pausing the video, you can, and trying it on your own. All right, so if you tried it on your own, hopefully you got this answer. If not, let's see what happened. Now, you don't have to just put logs. You can make it become a natural log. So it's up to you what you want to put in front. I'm going to stick with regular logs because that's what we might be used to. So I'm going to bring my x plus 3. Again, I'm going to use parentheses to be in front of what is being multiplied. I'm going to distribute. So this becomes x log of 2 plus 3 log of 2, x log of 6 minus 4 log of 6. So your answer might be different depending on how you manipulated. I'm going to go ahead and I'm going to manipulate this guy, and I'm going to move him all the way over here. So I get x log of 2 minus x log of 6. And then I'm going to take this guy, and I'm going to move him on that side. So I have negative 4 log of 6 minus 3 log of 2. So it all just depends on what you did. Right? They both have x's in common. So let's factor them out. So log of 2 minus log of 6 is equal to this long doodad. And then I get to divide. So log of 2 minus log of 6 onto both sides. All right, so we get roughly -4 log of 6 minus 3 log of 2 all over log of 2 minus log of 6. Again, this is an exact answer. If I want an approximate answer, let's plug this guy in. Now, there definitely have more things in my numerator, so we'd have to use parentheses. So -4 log 6, close that, minus 3 log of 2, close that, divide by, then open that denominator up, log of 2, and then minus log of 6. Close, close. And if you got about 8.416, good job. Again, this is the approximate answer.